Dani,
Sí, ¿me oyes?
sí, puedes empezar cuando quieras, ya empecé a grabar.
Perfecto, gracias.
Listo.
Good morning, everyone. We're going to go over today a quick training on access control. We're going to go over some of the basics, technologies behind access control, what goes into an access control system.
Charlie 1300. Charlie 1300.
Sorry about that, guys. So yeah, I'm gonna get started in about 15 seconds, just at 9 o'clock on the dot, to give a couple people some chance to log in, and we'll get started shortly, guys. All right. So once again, welcome everyone to the access control training today. My name is Daniel Gonzalez. I am one of the IP techs here in Sylmar, Miami. One of the Total Solution team members. So if you guys have any questions, I'll be able to answer them at the end of the training. But let's go ahead and get started. So we're going to go over a couple of the main purposes of access control. Why do our customers look or ask for access control? The biggest part with access control is security. So
Oh, is it? Oh, sorry.
hello. All right. So yeah, let's go ahead and begin again here. I don't know if everybody was looking at my screen or not before.
All right, what you got?
I'm with Protection Group USA. I don't know if she made that order.
She called yesterday. What did she order? She called twice, though.
I'm here for the key fob.
That's what you're here for? Right on.
Sorry about that, guys. We're just waiting on just a little bit of technical difficulty here on on the mute and stuff. So I'm going to begin again in just a sec here.
Dani,
Sí.
vamos a volver a empezar porque se estaba escuchando sonido ambiente de otras personas que tenían el micrófono encendido, entonces no estaban entendiendo. Y además, porque empezamos tarde la transmisión con respecto a la pantalla. ¿Listo?
Ok. Está bien, no, no empezamos de nuevo, no hay problema.
Dale.
Perfect. All right, guys. Sorry about that. Little bit of a technical difficulty here, but we're up and running again. Once again, I want to thank you guys for joining us today for the access control training. My name is Daniel Gonzalez. I'm one of the Total Solution team members here in the Sylmar branch in Miami. So I'm gonna kind of guide you guys today through a couple of just basic terms and reasons why why we sell access control and why a company would want access control. So let's go ahead and get started here. So what I was kind of mentioning a little bit before. One of the main reasons why a lot of companies want access control is for higher level of security, more than was really ever possible before with like lock and key. The problem with that technology is you can pretty much give that key to just about anybody, and that person can go ahead and open up all your doors in your business. So access control is a form of definitely improving on that security of that way. Also, you're able to view transactions and view reports of when somebody came in and when somebody came out of the location. Security goes hand in hand with what I talked about before, where in this case the cards are harder to duplicate, and they're obviously very easy to delete from your database or add in case of a new hire or if the card gets lost or stolen. Where, like I said, with with a brass key, you have to pretty much replace every single key. And the next part is flexibility, which is you can promote an employee, and with that promotion they'll have access to more parts of the company. So instead of having to give out a whole nother key, it's just give them access to that new part of the the company, or the new doors that you want that you want to give them access to, and they're off. So it's a, like I said, it's a simplified way to control security in a business. So there's really three types, not three types. There's three terms used for access control. The first is PACS, which stands for Physical Access Control System, and that's actually pretty much what we all think and know about access control. You also hear the term ACS, or Access Control System, or AEC, which is Electronic Access Control. One point that we want to mention is that it's different, or that those three terms are different from what's called LACS, or Logical Access Control System. Logical Access Control System is more like credentials on a PC or a database where you punch in a password. So if you hear Logical Access Control, you kind of think about logging into Windows, if you will, and the other ones are actual card-based access controls. All right. So some of the basic components you'll find in an access control system, you'll see in the picture on the right. You have your pretty much your heart of the whole system, which is your controller, your main controller, and that's where all the peripherals go connected to. You have your readers go connected to that. You have your locking devices like your door strikes, your mag locks. You have your contacts to tell you if the door is open or closed. And then you have your request exits. It can be anything from motion, a REX, to an exit button or a crash bar, and obviously a power supply and a UPS, which is going to be powering all these devices. Now the last part of the system is the actual database. So the controller itself goes connected to a PC or the data, or where the software is, and that software is where you're going to program the user's credentials. You're going to program, the doors and how they operate, and so on and so forth. So, like I said, you can think about the controller as the heart, but the brain of the operation, what actually tells the controller, if it's okay for you to pass or to open the door, or so on and so forth, is the actual software itself. Now, the controller does have some memory to control, or to remember, in case it does lose communication with the database. But you have to remember that that you cannot add or take off or pretty much make any changes without that software itself. Okay. So a little bit more about the controllers. The controller, like I said, has some memory, so it does take into account some of the the users in the system, if not all. Now, obviously, every controller has a different amount of memory, so it depends on how many how big that memory size is, how many people, or how many access control credentials it can remember. But it does actually have that memory in there. So if it does lose communication, the system will continue to work. It also has a knowledge of any of the programming that you inputted into the database, which is times, what time somebody can access it, when to lock and unlock doors, again obviously by schedule, pretty much the controllers are always going to be from 1 to 8 doors, or 1 to 8 readers, and I kind of like using the reader standpoint instead of the door standpoint, because it could be a little more confusing, and we'll talk a little bit about that in a second as to why I refer to it as readers instead of doors. And like I said, we'll get into that a little bit later. So actually I think that this one kind of we'll talk a little bit about that. So what if you have a situation that has more than 8 readers, or more than 4 or 8 doors, whatever the case is? Well, you can obviously or you can integrate or add more controllers into that same system. There's usually 2 ways that you can do this. One of them is via RS-485, which is a protocol to communicate between pretty much a master controller and then slave controllers. So you're going to have one master controller that's going to be connected to the database directly, and the other controllers are just going to be daisy chained off of that master controller, and they're going to be receiving their information once again from that master controller. Like I said before, you can have a controller that has one door but two readers, so that counts as pretty much two doors or two readers. That's why I want to make it a point for you guys to remember that it's not always about how many doors the customer is requesting. It's more about how many readers the customer is requesting. All right. And the second way to communicate multiple devices together, today, especially in today's industry, is via Ethernet. So a lot of these controllers can pretty much be put right on top of the door itself, and just with a simple network connection, have it communicate via to the database, and you don't have to worry about the slave-master relationship. You just pretty much network each of the controllers to a switch. Usually a PoE switch, which simplifies even battery backup. So in case of a power loss, you just have a battery backup on the PoE switch, and like I said, the controllers continue to function as normal. And like I said, it just definitely simplifies having to run so many cables to one location or to one door. I'm sorry about that. So like I said, on the top picture, one main thing that we wanted to bring up was that talking about that battery backup. If you lose that main controller when you're using RS-45, let's say the controller goes down or anything like that, that you pretty much lose what's behind that controller. So let's say you lost, unfortunately, the main controller. The main controller being that it was communicating itself with the database as well as the rest of the controllers, you'll actually lose access to the database that way. So one thing that you want to keep in mind when building these systems is using RS-45 gives you somewhat of a failure point, whereas using the Ethernet side, like I said, the failure point is just that one controller. If that one controller fails to communicate for some reason, being that the network is still up, the other controllers will continue to work. All right, so going into the actual software part, most of these access control systems rely on a database, an application that usually is multi-user. So you don't have you can have a person that has credentials to only maybe view transactions, to view when someone came in or came out. And you can have also credentials for like a master user, that master user is actually able to give new credentials, to change settings, so on and so forth. In this database, you pretty much have all of how the access control works in a software form. So it's gonna, in the database, you tell the database, how the controllers are configured, how they're connected. You're gonna tell the database how many doors and their configuration. You're gonna tell the database how many readers you have connected to it and also their configuration, any schedules. The card holders themselves get programmed into the database. And like I said before, operator configuration is, are you a master user or do I just want you to view transactions? Okay, and then obviously as well as access levels. Do I want you to have access to all the doors or just the ones that pertain to your department or your area? We do want to let you know that some manufacturers have included web interfaces to their program, which allows you to pretty much manage the software not only locally but also remotely, where you're able to add users, take pictures of that user, even obviously delete users from the comfort of your mobile phone. So you don't have to actually be in the office to do that. And usually these softwares, do have or are of graphical user interface nature, so you're able to actually see, the doors and how they function in a picture format instead of having to kind of guess in a command line or text style format. Makes the programming a lot easier. Okay. I kind of basically brush up on how the wiring works. One of the main points we want to take into consideration here is that there is a cable that exists that is specifically designed for access control. It actually has all the wires needed for the access control. It's going to have 4 different sets of cable. One of them is going to be for the keypad and the reader. One of them is going to be for power, for doors and locks. There's going to be other strands that are going to be for the PIR, the request to exit, and there's going to be 2 pairs for the door contact. So it's pretty much one cable, or one cable that inside has all those strands, and it definitely makes the installation a lot cleaner, a lot easier. But there are some things that we have to talk about when it comes to communication. Some customers ask for the utmost security, and we want to make sure that we're giving them that. So one main factor to take into consideration, and we put it on this slide, was that the wire that goes from the access control, the actual controller itself, to the reader should be a shielded cable. You want that wire to make sure that it's not going to get any interference from any outside noise, any outside reception. That cable needs to be transmitting the data from to the controller, in utmost perfection. There shouldn't be any kind of loss in data there. So that's why you definitely want to use a shielded cable, in that part of the system. Another thing that we want to take into note, if you are having the customer daisy chain the units, you cannot have a pretty much a total number in total. The entire job cannot have more than 5,000 feet for the RS-45 connection. Sorry, 4,000 feet, and a max of 1,500 feet in between panels. So just to kind of, I know that's a lot of numbers there, but just to kind of give you a little bit of idea of what we mean. We mean that from one controller to the other, it cannot be more than 1,500 feet. But let's say you have 5 controllers. Those 5 controllers in total cannot have more than 4,000 feet of cable interconnecting them. Okay. So this diagram also shows you pretty much normal cables that are used. So 22.4 is used for the PIR, the maglock 18.2, door contact 22.2. Those are just industry standards that are used, and if you have a customer that asks you, this will definitely become available for you guys to show to them, and also for your knowledge as to what cable to offer the customer when they're doing these access control jobs. This kind of delves a little deeper into that and where the cables go. So as you can see on the left-hand side, there's a main controller, and that main controller has inputs, outputs, and then the actual doors themselves. So the aux digital inputs, as you can see on the top left, that can be anything, as you can see there, from a PIR, motion detector, any kind of input that you want to activate or to make the system do something. You can have the system where if it sees an input from a fire to open the doors. There's the inputs are there for a lot of different things, but just to give you an example of what some of them might be used for. As you can see, the aux relay outputs on right next to that, or to the right of that, is the opposite of that. If somebody buzzes in, you can turn on a light bulb, or you can have a camera begin recording if the camera had an auxiliary input, or you can have a strobe light go off. Those outputs, like I said, you can pretty much dream what you want with that. On the bottom of that same image, you'll see next to the doors, to the right-hand side of all the doors, you have your exit buttons. To the left, you have varying forms of access control. So starting from left to right, the first you'll see a biometric reader. Just fingerprint. You put your thumb or an index finger on it. It's going to read to make sure that it matches what's in the database, and the door will open. The next one to the right of that is a combination of both. That's fingerprint and prox. To the right of that, you have just plain prox, and the last one to the right is keypad. So you can pretty much mix and match in the system. You can have a keypad one place, biometric in another, and just regular a regular RF anywhere else. You can definitely mix and match those, and that's how they go wired together. That's one version of how you do this. Now, a lot of manufacturers have started coming out with a single door controller, and that's pretty much the image to the right. And that single door controller, that controller pretty much gets mounted somewhere near the door, and it has all the inputs and outputs you would normally see in a multi-door controller like the one on the left, but more condensed for one door. You have your mag lock, your door contact, your exit button. You have your card reader and all that stuff directly directly above the door. You don't have to run cable from one door to the next. It's pretty much just that single door, and the only thing running back to a central location is more than likely either the RS-45 or the Ethernet cable to get it over to a database. So those are pretty much the two different forms that you're going to see for access control wiring. All right, let's get into a little bit of how the readers work. So there are a couple of obsolete stuff we're going to go over, but you might hear about it. So some of the physical contact, meaning you actually have to touch the reader in order for these access control forms to work, is magnetic strike. Once again, stripe, that was like a credit card. It has the magnet strip on the back. You'd pass it over a reader, and it'd open the door for you. Wiegand wire is another obsolete technology where it was similar to a magnetic strike. You had pretty much a cable with a coated wire inside. You would swipe and it would open the door. And the last is contact chip. That's actually still being used. A lot of credit cards nowadays are coming with it, where you have to actually slide the credit card into the reader, leave it plugged in for a little while, and then it downloads information into the reader itself. Usually you see that in government facilities, so we do want to let you know that does still exist. But those are the physical contact, where you actually have to put the card into the reader and then something happens. So contactless or wireless or RF technology are as follow. A lot of what we see, or a lot of what is obsolete in this market now, is the 125 kilohertz band. It's still widely used, but it's very low security. So if you have a customer that's definitely into security, which, I mean, if they're getting access control, they definitely want that security in there. You definitely don't want to recommend the 125 kilohertz cards anymore. They can be copied, and they can be, the transmission between the card and the reader has been pretty much compromised, or somebody has hacked it. So you'll see some of these technologies called HID procs or Indala procs. Those are, like I said, those are just different vendors using the same frequency, 125 kilohertz, to transmit the card's data to the reader. You also have some manufacturer proprietary cards, obviously, in that 125 kilohertz band. But like I said, what we really want the customers, or our new customers, to get into is the new technology, which is 13.56 megahertz. It's a two-way communication that goes between the card and the reader. It's definitely high security, and it has a built-in memory in the actual card itself. We're going to go over a little bit at the end of the slide of what the memory is for, but just to kind of get you into the technologies themselves, there's going to be two kinds of the cards you're going to find. You're going to find ISO 1443 cards. Those are usually the MyFair cards or the MyFair Plus. You're going to also see the Legic or the Desfire NXP cards. Some things to take note here: the MyFair card, once again, the plain MyFair card also has been compromised. It's been hacked, so that's why they came out with the MyFair Plus, the NXP card, and the Desfire NXP as well. So those are just higher security cards. The last, form of, the last communication or the last card you're gonna see are called ISO 15693s, and that's gonna be iClass from HID. And now, once again, that one kind of it probably got compromised. So HID came out with a new one called CEOS or SE. So you'll see iClass SE or iClass CEOS. What the difference is between these cards is just how much is security in reality. How much data you're transmitting from the card to the reader, and that data is encrypted. So as long as that encrypted data stays encrypted, well, these will probably be the cards that you're going to see. Like I said, unfortunately, the way that the technology works, there's always somebody kind of working against security. So, for now, this is the most high security that you're going to find. So if you have a customer that's looking for, definite security, he doesn't want anybody to be able to duplicate cards. He doesn't want cards to be, just a guessing game as to whether it works with his system or not, you definitely want him into the 13.56 megahertz frequency. Now the memory in the card is a little bit different. The memory on these cards is just for keeping track of either in and out. You can have that memory, can keep track of how many times you came in or how many times you came out on the actual card itself. So it's not the actual access control software doing it, it's the actual memory card itself. You can even think about it in a use in a cafeteria where their access control is also their cafeteria card. You have a certain amount of money loaded in that cafeteria card, and you can just use the same card to buy, like I said, food or whatever the case is. A lot of universities are using that nowadays to pay for certain things around the school. All right. So some of the credentials you'll normally see are cards. Cards usually come in two forms, printable or clamshell. It's really preference. If the customer wants a printable card and doesn't mind spending a little bit more, we can definitely sell them the printable card. If he wants to save some money, we can give him some clamshell cards, which are less, they're more cost effective, and you can maybe put a sticker on it or something like that gives them the printable ability on that card and save them some money. You'll also see key fobs, so that's pretty much what you'll dangle along your keys. Nothing new there. It's just, like I said, just a key fob as you would see pretty much anywhere else. You normally see those in apartment buildings because they're smaller, and like I said, they kind of just fit in your key. The next thing you're going to see a lot of are tags or key tags. Those are the difference between a key fob and a key tag is adhesive. So the tags have to be adhered to a surface. The surface can be pretty much anything. But it does have to be adhered. There's not a key ring or anything to hold it down. We see a lot of those in inventory management where that gets pasted in on the laptop or inside of a computer or something like that, and it just it's if somebody needs to rent out a laptop, they can just beep the laptop across and they know that the laptop has been sent out, and vice versa when it comes back in. Now the new technology that we're seeing is cell phones. So our cell phones nowadays have a technology called NFC, which is near field communication, and what that is pretty much using your phone as the credential or the access card. From what we've seen, different vendors manage this differently, but we do see that it does incur a cost per phone. So it's a great technology because everybody has phones. Usually everybody has it in their hands when they're coming in the morning. But like I said, it does incur a little bit of a cost that the customer might not want, but it is an option that we can offer them. You also see window stickers, which is the bottom image. The window stickers you'll normally see obviously stuck to a car, in a garage, and those usually go paired with a long-range card reader, because obviously normally card readers can read a card between 8 to 10 inches away, no more than that, where the actual car is going to be further than that. So these long-range readers will usually go about 10 to 15 feet, read the window sticker, and grant access. Okay, one thing to take into consideration when looking at credentials is to make sure that it works with the compatible reader. In the previous slide, we went over two different frequencies. The one was more secure than the other. When migrating a customer from the 125 frequency to the 13.56 frequency, you can sell them a multiple, reader that has multiple, or the ability to read both of those bands, but you still have that security in question, where because the reader can read these older, the 125 megahertz card, you're kind of being a little bit vulnerable there. But that's where it goes hand in hand with just make sure that whatever credential you're selling the customer is compatible with the reader itself. Either you're selling them one or the other. That's up to the customer. Okay. So different formats of the cards. Once again, the format is just how the data is arranged within the actual card or the memory in the card. The most common form of data or encryption in the card is 26-bit. That's, like I said, I would say covers probably 80% of what we deal with. But anyone can order this card. That's what the next point says. That's the problem with that, is anyone can order that card. Anyone can order a 26-bit card. So your system might have the same card as your next door neighbors and so on and so forth. So to kind of combat that, HID came out with their own format. It's 37-bit. It's fully controlled by them. They have literally control from the first card they ever made to the last one they're ever gonna make, and that just makes sure that it makes sure that that there's no duplicate cards out there. That one card will never be produced again. So that's one added benefit of the HID 37-bit format card. All right. The next thing we're going to talk about are locking devices. So this is pretty much how you control the actual door itself. So you normally see two kinds of locking devices: door strikes, which is the top image, and magnetic locks, which is the bottom. There are obviously different variants of each. There's going to be mag locks for gates. There's going to be mag locks for outdoor use, but in general, it's a mag lock. And you're going to have door strikes that actually, lock the door from the handle. Some of them are called plungers, where it's a device that goes in the floor and pops up through the bottom of the door and holds the door that way. But like I said, they're usually either door strikes or mag locks. And then you're going to hear two designations when it comes to access control and actually locking the doors. What's called fail-safe and fail-secure. I'm going to spend a little bit of time here because I believe this is a pretty important part of the presentation and what they mean. So fail-safe pretty much means that it will lock with power. So and the problem with that or that's really what you want. You want to be able to exit. You want the people to be able to exit the premises or the building that's got the access control in case of an emergency. Where fail secure will unlock with power, the opposite of that. So once again, in that situation, if there's some sort of a power failure or something, you don't want the people to be trapped inside with a mag lock. You want them to be able to actually go outside. Okay, so a lot of times the fail secure isn't always legal or fire departments don't allow it because of that, because it does create somewhat of like a prison, if you will. And that's definitely not good in case of a fire or an emergency when somebody's trying to egress into the building or get out of the building.
Danny?
Yes.
Isn't fail safe unlock without power?
So fail. Yes, I'm sorry. I think we might have confused them. I'm sorry. Fail safe is.
Or fail secure. Sorry. Yeah. Fail. Fail. Yeah. I don't know.
Fail safe is that no matter what happens, like I said, the system is exactly, it's open when like to let people out. Fail secure is, once again, is the system is locked down because it didn't have power.
Gotcha. Okay. I see how you worded it. All right. Thanks.
Sorry about that confusion, guys. Thanks.
All right.
Thanks, guys. All right. So moving on to some special functions that we can actually accomplish with access control. So the first we're going to talk about is anti-passback. So anti-passback is a method to make sure that the employees are pretty much following the rules that you set. What it means is pretty much you have to go through order of operation here. In order for me to get out of the building, I would have had to have come in, and vice versa. In order for me to go in the morning and come back out later on, like I said, I had to actually have been in that first reader when I came in the morning. It pretty much just avoids the use of the same card by multiple people. So let's say I have a reader and I buzzed myself in and I left my card there for the next person to use my card to come in again. It won't work because the access control system is saying, wait a minute, you already buzzed in. The only way I can let you use this card again is if you leave or you come back out. Okay. So like I said, a simple, like the picture illustrates, a simple anti-passback is two readers, one in, one out. You have to go through one to go to the other. And like I said, it goes both ways. So you can have it where if the person didn't leave the day before or didn't buzz out the day before, they can't get back in. Just to make sure that you can talk to him and say, hey, you know, next time make sure you buzz yourself out before you leave. Okay. Now, anti-passback has different kind of forms. That one, what we talked about, was one of them. There's another one called timed anti-passback or soft anti-passback. There's just two different forms of how to use it or how to word it. And this is pretty much just the same thing. It's used to discourage the sharing of cards. But it's usually used in parking lots where the person might use that card later on in the day. What you don't want is the person to buzz themselves in, you know, repeatedly. So you don't want one person sharing the card. Is pretty much what it means. So let's say I had a turnstile like the one in the picture. I buzz myself in. My card will not work on that turntable for, I don't know. I can set it to whatever I want it to be. You know, either all day and it resets the next day, or an hour, whatever the customer wants to program it as, you can program it. And it's like I said, it's just so that you don't have, once again, you know, two different users using the same card in the same location. Okay. And then the last one, or not the last one, this is the second last one, is called nestled anti-passback. So this is pretty much, it requires areas to be defined, and this is really used to control where people are. You want to make sure that, let's say, you have somebody in one location and you know that that person is there. So and this slide will kind of help you a little bit to, you know, to understand what that means. So let's say I come in from the outside, I beep myself in, and now I'm in area A. What the advantage is that you can get a report, and that report will tell you when that person or how long that person spent in area A. Now, if I give my card to someone who made their way to area B, that person will not be able to buzz themselves from area B into area A because I never left area A, or my card technically never was buzzed out of area A. But if I do move from area A to area B by actually using my card to get me there, the anti-passback will remember or will keep log that I was in area B. So kind of what the chart on the right says, not in facility. So that's a list of people that were never in the facility, or might have been outside. Okay, it's what's called a mustering report. And it in area A, you'll notice that, okay, area A was Ruth, Jean, Don, so on and so forth, and area B the same thing. So it's pretty much a report, or what's called a mustering report, and that allows you to see who was where at what time. In case of an emergency or in case of an accident, I'm able to tell you exactly where the person was, you know, in that area, and at what and for how long. All right. So the next one, regional anti-passback. So this one requires an entrance and exit reader in the perimeter of the building. So this one is really in case you know, of really, this one's really good for time and attendance. So if you have somebody buzz themselves in the morning, you recorded what time they came in and what time they leave. But what if, you know, you have an ability to, or you have a back door that doesn't have any access control, and you're able to make your way in that way because you came in late that day and you didn't want anybody to know? Well, your card will not work unless presented in one of those perimeter readers first. So pretty much what that means is, if he did get in, like I said, maybe using an emergency exit or somebody opened the door for him, and later on he wanted to go to the lunchroom, his card won't work because according to the access control system and anti-passback, he was never in the building to begin with. Okay, so these are just different forms or different settings that you can put on these access control systems that allow you to, like I said, once again, enforce rules. You're gonna, you know, you don't want anybody to just show up in the morning. You want them to beep themselves in so you know when they're in, what areas they're in, and so on and so forth. So that's where anti-pass comes into play. All right, so moving on to elevator controls, and we get this a lot here. A lot of customers think that elevator control is pretty much just putting an access card in front of the elevator and then having the elevator door open when you present your access card. And that is one form of elevator control, but not the most secure nor the best. So most elevator controls that we get asked for is actually in the elevator cab itself. And And it pretty much replaces, it doesn't replace, it works in conjunction with the elevator button itself. So what you do is, you have a resident, let's say a building with, in this case, 14 floors, as you can see on the image to the right. So what you're going to do is you're going to give that resident access to their floor and any common areas, maybe the RF, the roof. So when they open up the elevator, anybody can call the elevator, anybody can open the elevator door. But once they're in the elevator door, they have to present their credential, present their prox card. Once they present their prox card, the access control is going to give them access to any of the floors that they were programmed to have access to. Let's say I lived on the 7th floor. When I beep in my card, I can press number 7 and it'll let me go up to my floor or roof because it's a common area. Now if I lived in the 7th floor, I beep my card and hit 9, I won't be able to go onto that floor. So it pretty much just controls controls where people have access to in a specific building. It's great for not only residential buildings but also commercial buildings where the same building might be shared by different companies. Well, if I work in a company on the 7th floor, I don't need access to the 10th or the 11th. So I just buzz myself in, I get access to my 7th floor, and we go from there. So that's pretty much elevator control in a nutshell on how it works. So once again, don't think of elevator control as actually calling the elevator down. It's more of what floor can I go to, or what floor can I have access to. All right, so another technology, not another technology, but another kind of setting that you can have on some access control systems is called Mantrap. So typical Mantraps are usually doors, and in which one door needs to, is obviously open, then closed, and then there has to be some sort of other credential presented to go into the second door or the secure area. I've seen these a lot in banks where you have a security guard in that Mantrap area. He's gonna let you in the first door, but then if he sees, maybe he feels that you're being a little sketchy, or he sees maybe you have a weapon on you or something along those lines, well, he will not grant you access to the second door, and now you're stuck. You can go ahead and call a police officer or law enforcement, whatever the case is, and that person is now stuck in this Mantrap. Now he might be able to go backward and go back out, but he won't be able to at least go into that secure area. We see it a lot like I said, in banks. You'll see this maybe in a hospital where there's a clean room on one end and a lobby or a regular room on the other. So there'll probably be an on guard or somebody there just making sure that the person that goes into the Mantrap is able to actually continue to the second door. If not, like I said, like the name implies, he's trapped in that little room, either going back or not going in. So it's, like I said, it's added security in cases where you don't want anybody that's either volatile or trying to harm someone move into that location. Okay. And the next, we're going to go into multi-factor authentication. So this is pretty much just talking about when is it necessary to authenticate the person presenting the card. In this case, let's say, for example, I don't want my employees passing around cards. This is a big factor. So you can kind of go about it two ways. You can go about it with fingerprint reader, or you can so the person has to not only give their thumb, but also buzz in their card. One kind of, you can think about this as like your ATM card, your bank card. When you go to an ATM to put in money, not only do you have to present the card, but it also asks you for a PIN. Same thing here, and it can be 3 or it can be 4 different authentications that you need. You might need an access card with a PIN and the biometric. It's just it's just, like I said, added security. Anyone can pass a card around, but not everybody can pass a thumb around in that case. And this kind of goes into the biometrics that we were talking about. So, what are some forms, or how can I, what are biometrics? What are some of the forms of biometrics? So the most common that you'll see, fingerprint, palm scan, hand geometry. If anybody's listening down here in Miami, they know what hand geometry is. We clock in and out with that. iris scan, so using your retina or what your eye looks like in comparison, to somebody else's. Everybody's iris is different. Signature dynamic is, you sign a piece of paper or a little diagram, and if your signature is pretty close to what it usually is, it'll let you in. Keyboard dynamics, voice print, facial scan, hand topography. Those are all forms of biometrics. Those are all items used, to kind of grant access or to make sure that you are you. But most of what we see in the industry nowadays is fingerprint. So fingerprint, you pretty much present your finger up to the reader, you buzz in your card, the door opens, and that's what they mean by multiple, means of verification. Okay.
No problem. It looks like it's poured, but somebody took a little shot here. Sorry.
No problem. Thank you.
Hello, guys.
I'm sorry.
No problem. So one thing that we also want to talk about is integration with other systems. So, I mean, I would say the biggest thing, the most commonly seen integration with access control is fire, obviously, because the fire panel has to deactivate the power supply for mag locks. So you can call that a form of integration. But you can also integrate your access control with your cameras, which adds even more security to the system. So if somebody beeps in, you have a guard that gets a picture of who's getting beeped in, making sure that the person didn't share his credentials, or also making sure that the person is who they say they are. You can also integrate the access control with your alarm panel, and if you have the right credentials, you can double pass your card and deactivate a partition in where you work at, or double tap a card and arm the alarm. You can also do integration with air conditioner, like I said, first man in, first man out kind of integration. So we want you guys to remember that if you're selling an access control job, and they want integration, we can definitely do it. We have products to do it. We have the knowledge to do it, and it's just going to give the customer a more secure system. And at the end of the day, I feel that's kind of what we're talking about here, what this whole conversation here, this whole training has been about. It's been about security, and we want to kind of migrate the customer from the old kind of stuff that, granted, it worked, but it's not as secure now. We want to get them into the driver's seat of something that's definitely secure, and that's a whole total solution with cameras, CCTV, with access control, with their alarm, with like I said, with their HVAC systems, all that stuff pretty much in one area, one location. All right, and that's pretty much about it. That's all the time we have for now. Do you guys have any questions that you might that you need answered, or anything that might have come up during the presentation? All right.
Just the elevator control, if you could go back over that.
Sure. Okay. What about the elevator control?
I just had a phone call during that. I just wanted to see if you could just go over that just real quickly.
Okay. So pretty much what happens in elevator control is the following. And then I'm going to go ahead and open this up from current slide. All right. So the way that an elevator button normally works, imagine it being, pretty much you press the button, it opens up a relay that controls the elevator and tells the elevator, okay, go to floor number 7. Okay. So what this does is kind of work in conjunction with that. So there's pretty much a relay board that goes in the elevator panel, if you will, or behind the elevator door. And that elevator and that panel, when you present your credential, that panel knows what relay you have access to. And when I say a relay, I really mean a floor. What floor you have access to. So when I buzz in, when I beep my card, I tell the relay board or my access control system, okay, this card has access to floor RF and floor 7. So the relay for floor RF and the relay for floor 7 open up. Mm-hmm. Now the elevator is still not doing anything. I haven't completed the circuit telling the elevator where to go. So I go ahead and hit either 7 or RF, for example. Because the relay was open for 7, it will allow me to actually go to that floor. Now, going back, if I remember, I only said I had access to floor 7 and floor RF. If I press floor 8 or floor 6, being that the relay is closed for that floor, it won't let me press the button. It's pretty much like I press the button and the elevator can care less. Why? Because the elevator controller never received a command because the relay blocked it. The access control relay blocked that command from going to the actual elevator itself. Did that make a little bit more sense?
Yeah. Mm-hmm.
Okay. So then, I mean, and obviously you can always include us in these elevator control designs. You pretty much need a relay per floor, and there's a certain amount of relay boards. Obviously, it even goes further as to how many cars or how many cabs you have and how many doors the cabs have. So, like I said, it's a little bit more in depth than what I have time to explain in this training.
No, yeah, I actually get that. I was thinking more of the fire relay deal, but that's cool. I get this one. You're good.
Okay. All right. Well,
thank you.
Thanks a lot, guys.
Presentation.
Thank you. If you have any other questions, you guys know my email. It's dgonzalez@silmarelectronics.com. I can definitely help you guys out with any questions you may have. All right. Thanks a lot, guys.
All right. Thanks, man.
No problem.